Students, this is Rasmi Biswakarma, Assistant Teacher of Nisangram High School. Today we are going to start with our part 3 video of periodic classification of elements of class 10 science. In today's video, we are going to discuss the modern periodic table. Okay? In the year 1913, Henry Moseley, remember this name Henry Moseley, shows that the atomic number of an element is more fundamental property than its atomic mass. Okay? Do you understand what is atomic number and atomic mass? I have already discussed about atomic mass, and atomic number is the number of proton present in a nucleus, right? So Henry's shows that atomic number of an element is more fundamental property than its atomic mass. So the modern periodic table is based on the atomic number instead of atomic mass of an element, right? This is your modern periodic table. Okay? Henry Moseley has arranged these elements, all these elements, in this periodic table, and it is only based on their atomic numbers, right? So in this table there are 7 periods and 18 groups. Okay, so in the right side there are metals, in the left side there are metals, and as you go from left to right, you find there are more number of non-metals, and the box shaded color is the metalloids. Okay, so we will discuss in detail. And there are also lanthanoids and actinoids group, which is the heaviest atom, or also known as radioactive atoms. Okay, let's start with modern periodic laws. The physical and the chemical properties of elements are the periodic function of their atomic number. Okay, I've already mentioned this. Modern periodic table is based on atomic numbers of an element, right? Atomic number, which is denoted by the letter Z, is equal to the number of protons present in the nucleus of an atom of an element. I have already mentioned this. Okay, on moving from left to right on a period, the number of the valence electron increase from 1 to 8 of an element present. Okay, this we will discuss in detail. Have a look to this diagram, how we kept the electron in a cell. Okay, so sodium, centermost is the nucleus. There are many cells, K, L, M, where sodium atom has atomic number of 11, right? So we kept this number of electron 11 like this. Okay, all protons are present in the nucleus only, but the electrons are distributed in the cells. So we keep all this electron, like in the first cell there are 2 electrons. In the second cell, how much electron is there in the second cell? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 electrons, right? And at last, in the last cell, there are only 1 electron. So it has completed its octet in the second cell only. So from the last cell, it will release its electron and complete its octet and make it complete. So on moving from left to right in a period, the number of valence electron increase from 1 to 8 in an element presence, right? So in the next point, there are on moving from left to right in a period, the number of cell remain same. Okay, we have already discussed about the cell, that the number of cell will remain same. In the next point, all the elements of a group of a periodic table have same number of valence electron. I have already discussed this, because in a group there are only there should be same valence electron, okay, in one group. So for example, in the first group, hydrogen, helium, lithium, sodium, potassium, rubidium, cesium and francium, there is one valence electron. In the whole atom there will be one valence electron. In the second group there is two valence electron. Like that we will come to know all its valence electron. Okay, if you find its valency like that, how I have discussed, we have to complete its octet, and then the remaining last cell electron will be received or removed as the element required to complete its octet number, that is 8, right? Trends in modern periodic table, they are valency, atomic size, metallic and non-metallic characters, and electronegativity. Valency, the valency of an element is determined by the number of valence electron present in the outermost cell of its atom. I already discussed this. In periods, on moving from left to right, that is from group 1 to the last group, that is 18 group, in a period, the valency first increase from 1 to 4 and then decreases to 0. Okay, for example, lithium, the first group, that has one valency, beryllium has 2, boron has 3, carbon has 4, nitrogen has 3, and then it will decrease, like oxygen has 2, fluorine has 1, and neon has 0. In groups, on moving from top to bottom in a group, okay, top to bottom means from hydrogen to the last atom, that is rubidium, in one group. In the first group, the valency remains same. Valency will remain same in the same group, right? Because the number of the valence electron remain the same. Okay. For example, valency of first group element, that is equal to 1. Valency of the second group is equal to 2.